These are two 8-digit LED displays which I used when I made my DRO. I bought quite a few of these. I made a prototype DRO using a PIC microcontroller, and then I moved on to an ARM microcontroller. During the process of doing the prototyping, unfortunately I found two faulty displays. I don't think I blew them up, I think they were actually faulty when they turned up, so I may have damaged them, I can't remember. But anyway, these chips don't work. I've bought some more subsequently, so this isn't actually junk. So what I'm going to do is take these LEDs off. Sorry, not the LEDs, the LED drivers. Take the drivers off and we'll decap them and have a look inside, see what the circuitry's like. Should be fairly simple. Hopefully I can do it without destroying the boards, because I do want to try and put some new chips on here. I'll get the air gun out, heat it up a bit, maybe I'll reduce the temperature a little bit, we'll go down to 350. Somewhere in the 300s, let's see if we can, yeah, so that's melting the solder. What I might do, I think, is put that in a vise so it's less hands are needed to do what I need to do. That way should be able to pull it off with the tweezers fairly easily. Lines of melted solder there. Looking good. Come on. Of course, taking it off, I don't really care whether I overheat the IC or not. It's going to get a lot more heat than we're giving it here. Let's do a second one. There's a lot of flux on these boards. So we'll take that off now. Pretty close. There we go. Done. So two boards. Looks like that's come off quite cleanly. That looks quite nice as well. I'll remove the solder around here with desoldering wick before I solder a new IC on, but that's a project for another day. The ICs, I think we'll decap those. This is the 7219 LED driver, serial LED driver chip. Again, there's quite a lot of damage here due to the decapping process, but there's quite a lot that's visible. It's around the edge of the chip, the die pads, bond wire pads. So we've got quite a lot of pads around the outside, and a lot of space is taken up by the pads. I think these could be large transistors here, because there is quite a current driving capability with this chip. So we do have large output transistors, it looks like. And then in the middle we've got the logic, which is difficult to make out, at least at this magnification. It's difficult to actually spot the shift register that must be in there somewhere. But there's not a lot of it, that's it. There's some numbers there. I'll switch in the high magnification objective and bring that into focus. There we go, so we can zoom in. So it's a bit more detail maybe. So what we've got there, we've got a number there. Not sure what that says. NL858 maybe, or is it upside down? I think that might be the right way up, not sure. But this is modern technology and it's minuscule. Very, very small, densely packed. Can't spot the shift register at the moment. It's probably going to be a 64-bit shift register in there somewhere. But yeah, that's... yeah, I might be able to get some more information out of this one. But we'll see. I'll maybe do a die shot of it, although it's got a lot of dirt on it, so it's not really going to come up very nicely.